Have you ever imagined a spacecraft so far from home that sunlight takes over 20 hours to reach it? Voyager 1, launched way back in 1977, crossed into interstellar space in 2012, becoming the first human-made object to venture beyond our solar bubble. Its instruments, believe it or not, continue to relay whispers from the unknown, probing regions where cosmic rays and magnetic fields dance in this kind of eerie harmony. Here's the punchline. Voyager 1 is still alive, and it's over 14 billion miles away. Did you know its tiny plutonium power source will last until around 2025? Impossible encounter in deep space. A tiny spacecraft more than 14 billion miles from Earth suddenly shook the foundations of modern astrophysics when Voyager 1's instruments recorded an astonishing, milliseconds-long burst of high-energy particles unlike anything seen before in interstellar space. In that instant, every sensor on the probe lit up with an organized waveform, ruling out random cosmic noise and forcing engineers to confirm that this was no mere hardware glitch. At the same moment, Voyager's gyroscopes detected a subtle twist in its orientation, as if an unseen hand had tugged on the craft, and the usual 22-hour round-trip signal delay to Earth shrank by a fraction of a second, hinting at a fleeting distortion in the fabric of spacetime itself. No gamma-ray burst, supernova, or solar storm shows up in astronomical records for that region, leaving experts scrambling through three impossible theories: an extraterrestrial device projecting a focused energy field, a pocket of dark energy that warped electromagnetic propagation, or an interaction with a rare plasma filament weaving through the interstellar medium. Each hypothesis challenges the very core of physics textbooks, demanding we rethink how energy, gravity, and the unseen architecture of the void behave beyond the heliosphere. In the silent expanse beyond our sun's protective bubble, Voyager 1's incredible anomaly reminds us that even the emptiest reaches of space are alive with mysteries, waiting for humanity's farthest-flung explorer to uncover secrets that could rewrite our understanding of the universe. Glitch, just mystery. Voyager 1's ground team stared at the data readouts in sheer disbelief as every single diagnostic test came back pristine. No corrupted memory blocks, no voltage fluctuations, no code errors, nothing to explain the extraordinary energy burst. Systems older than most smartphones performed flawlessly under scrutiny, with checksum verifications confirming every line of onboard software was intact, and temperature sensors reporting nominal levels despite the ferocious particle spike. Even the legendary fault isolation protocol, designed to reroute power and reset malfunctioning modules in mid-flight, lay unused because there simply was nothing to reset. Engineers pored over thousands of telemetry frames, tracing each bit of data back through redundant pathways, and found no evidence of internal interference. If Voyager 1's ancient circuitry didn't generate the anomaly, then whatever happened out in the abyss must have been real, an authentic encounter etched into the probe's history. In that moment, confidence in Voyager's hardware soared alongside excitement for new possibilities, because ruling out a spacecraft glitch meant there was something truly alien at play in interstellar space, taunting our understanding and daring us to chase answers farther than ever before. Voyager 1's celestial Morse code. Voyager 1's data stream suddenly morphed from random static into what looked like a cosmic Morse code, a patterned pulse that left scientists both thrilled and baffled. In a fraction of a second, the probe's particle detectors and magnetometers synchronized to reveal a series of evenly spaced energy peaks, as though an unseen hand was tapping across the void. This wasn't the chaotic hiss of solar wind or the harsh roar of a gamma-ray burst. Each pulse repeated with hypnotic precision, spanning multiple frequencies and lighting up every instrument on board. Mission specialists pored over spectral analyses and discovered that the waveform bore hallmarks of an engineered signal: consistent amplitude, regular intervals, and a frequency sweep that traced a smooth arc, rather than flickering unpredictably. Even more astonishing, the pulse sequence carried subtle variations, tiny shifts in timing and strength, that hinted at encoded information rather than a simple periodic disturbance. It was as if Voyager 1 had intercepted a secret broadcast, one crafted by forces beyond human technology. The phenomenon forced researchers to rethink assumptions about interstellar space being a purely random environment. It suggested that pockets of order could exist out there, whether born from exotic plasma structures, alien transmissions, or unknown quantum processes. Deciphering this patterned pulse has become a top priority, with teams applying advanced signal processing algorithms and machine learning models to tease out possible messages or physical explanations. As Voyager 1 continues its lonely voyage, every bite of this mysterious waveform could unlock groundbreaking insights into the hidden rhythms of the cosmos, and remind us that even in the deepest darkness, order sometimes whispers its presence in the language of light and energy. An unseen hand in the abyss. Voyager 1's gyroscope suddenly whispered of a cosmic nudge, an invisible twist that left controllers back on Earth scrambling for explanations. In the span of mere milliseconds, the probe's attitude sensors detected a subtle, inexplicable rotation, a change so slight it couldn't have been caused by solar pressure or micrometeorite impacts, yet unmistakable in the spacecraft's precise telemetry. Engineers pored over torque calculations, eliminating every conceivable onboard cause, fuel slosh, mechanical backlash, thermal flexing, until they were left staring at a phenomenon with no terrestrial analog. It was as though an unseen hand had reached across the void to give the billion-mile-old Voyager a gentle spin, bending the laws of momentum in a region we once believed too empty to exert any force. The unexpected rotation coincided exactly with the instrumented energy spike and patterned pulse, weaving a narrative of interconnected events that defy random chance. This phantom torque raises profound questions. Could Voyager have grazed a dark matter stream whose gravitational tides imparted enough leverage to twist the craft? Might it have skimmed the edge of an interstellar shockwave, where charged particles funnel a directional impetus? Or more tantalizingly, did it encounter an alien probe deploying micro-thrusters in a silent salute to humanity's farthest emissary? As research teams model this ghostly rotation, high-fidelity simulations and laboratory plasma experiments strive to replicate the torque under controlled conditions. Each test brings new clues and fresh mysteries to light. Voyager 1's unexpected pirouette reminds us that even in the supposedly tranquil expanse beyond the heliosphere, forces unseen and unfathomable still hold sway, challenging our understanding of motion, matter, and the mysterious ballet of the cosmos. Accelerated echo. Voyager 1's routine ping suddenly arrived back on Earth faster than light-starved engineers had ever seen, its 22-hour delay shaved by a mind-bending fraction of a second, hinting at a fleeting shortcut through the cosmic fabric. As mission controllers compared timestamps, they realized the signal's return lag dipped by nearly 0.02%, an anomaly far beyond measurement error, and repeated across multiple tracking sessions. This wasn't a glitch in ground station clocks, atomic time calibrations held steady, nor a misalignment in the Deep Space Network antennas which showed perfect pointing accuracy. Instead, the only plausible culprit lay between the stars, a transient wrinkle in space-time itself. Some researchers propose Voyager skimmed the edge of a gravitational lens formed by a dark matter clump, bending its own radio waves and hastening their journey home. Others theorize the probe drifted through a localized warp bubble, an exotic distortion predicted by general relativity but never before observed, compressing the distance light traveled by mere thousands of kilometers. Intriguingly, this temporal quiver aligned with the same instant as the energy spike and phantom torque, weaving a tapestry of interlinked anomalies that defy conventional astrophysics. If confirmed, this phenomenon offers a rare glimpse into how gravity and quantum effects interlace across interstellar scales, potentially unlocking new methods for faster-than-light communication or propulsion. Engineers are now reanalyzing decades of archival data for similar micro-shortcuts, while theoreticians refine models of spacetime foam to account for Voyager's cosmic detour. In the silent expanse beyond Neptune's reach, Voyager 1's accelerated echo reminds us that even the void can surprise, revealing hidden pathways through the universe that beckon humanity to rethink the very nature of distance and time. The Cosmic Detective Story. Voyager 1's ground team frantically cross-referenced every astronomical database on Earth, searching for the cosmic culprit behind the impossible energy burst, only to discover that the universe had gone eerily quiet at the exact moment of the encounter. No gamma-ray bursts lighting up distant galaxies, no supernovae explosions sending shockwaves across light-years, no solar storms from our own sun rippling through interstellar space. Absolutely nothing to explain what had just happened to humanity's most distant explorer. The Deep Space Network's massive radio dishes, which normally detect the faintest whispers of cosmic violence from billions of miles away, registered complete silence in Voyager's sector during those crucial milliseconds. Even more puzzling, the probe's location placed it in what astronomers call a cosmic desert, a region so devoid of stellar activity that it should have been the most predictable, boring stretch of interstellar space imaginable. Teams scoured records from the Hubble Space Telescope, the Chandra X-ray Observatory, and ground-based gamma-ray detectors, finding no trace of the high-energy phenomena that typically produce such dramatic particle spikes. The absence of any conventional explanation forced scientists to confront an uncomfortable truth. Whatever had interacted with Voyager 1 wasn't broadcasting its presence to the rest of the universe. It was as if the cosmos had conspired to create a perfect mystery, leaving behind only the faintest fingerprints on a single spacecraft drifting through the void. In the vast theater of space, where violent stellar deaths and explosive births paint the darkness with radiation, Voyager 1 had encountered something that preferred to remain hidden, making its discovery all the more extraordinary, and, honestly, a little terrifying. Alien architecture. When Voyager 1's detectors lit up with that impossible energy surge, engineers never suspected they might be witnessing the handiwork of an alien civilization experimenting in the dark. Suddenly, this 4-decade-old probe recorded a beam of finely tuned particles, not chaotic like a cosmic blast but precise, like a message or a probe's beacon interrupting interstellar space. Analysis revealed the burst carried hallmarks of intentional design, sharp rise and fall patterns, frequency shifts matching the characteristics of directed energy systems, and a coherence so perfect that natural plasma interactions could never replicate it. As the burst faded, Voyager's orientation sensors registered micro-adjustments in its attitude, as if tiny thrusters had nudged the spacecraft ever so slightly, another signature of a remote station device calibrating its aim. Experts theorize that Voyager may have passed through the scanning field of an extraterrestrial sentinel, its beams designed to map atomic structures across vast distances or to ping interstellar vessels for contact protocols. Alternatively, some propose that an alien research platform deployed a stealth drone using advanced metamaterials to cloak itself until it communicated with passing artifacts like Voyager. In either case, this encounter suggests that we're not the only technologists in our galactic neighborhood. Perhaps somewhere out there, hidden between the stars, lies an extraterrestrial network of sensors and beacons, silently cataloging the interstellar medium and cataloging every human-made emissary that dares to venture beyond its home system. Voyager 1's brush with alien technology isn't just science fiction come to life, it's the first breadcrumb on a trail that could lead us to the architects of the cosmos, challenging humanity to listen more closely to the silent symphony of space. Dark energy pocket. So, a sudden distortion in Voyager 1's data hints that the probe may have drifted into a pocket of dark energy, a region where the mysterious force accelerating the universe's expansion really takes center stage. In this hypothesis, Voyager 1 crossed into an extraordinarily empty patch of space, way emptier than the surrounding interstellar medium, where the repulsive effect of dark energy briefly overwhelmed all other influences. Instead of the usual cosmic rays and plasma interactions, the spacecraft detected these subtle shifts in its electromagnetic signals, frequencies that stretched and compressed as they moved through a volume governed more by spacetime's expansion than by local matter. Within such a void, even light itself could experience a tiny pull outward, altering round-trip communication delays and bending radio waves in ways never observed inside the heliosphere. Now, laboratory tests and cosmological simulations suggest that dark energy-dominated voids can produce minute phase shifts and amplitude modulations in traversing signals, effects that would show up on Voyager's instruments as coherent anomalies rather than just random noise. If Voyager 1 truly sampled a sliver of this cosmic foam, its data offer us the first direct in-situ glimpse of dark energy's influence on electromagnetic propagation. Confirming this pocket would not only rewrite our understanding of the interstellar medium, but also provide an unprecedented laboratory for testing whether fundamental constants remain unchanged in regions where dark energy reigns supreme. As Voyager 1 sails deeper into the void, every distorted waveform and delayed ping may map out the hidden architecture of the universe, and reveal how the silent force of dark energy sculpts the fabric of spacetime itself. Plasma filament interaction. Voyager 1's sensors just whispered of a hidden highway in the void, a dance with a ghostly plasma filament that left its instruments singing in synchrony. In the blink of an eye, the spacecraft crossed through a slender strand of interstellar plasma, an elongated ribbon of charged particles threaded by magnetic fields that acted like a cosmic waveguide. As Voyager tore through this filament, its detectors recorded a series of harmonized energy pulses and subtle magnetic fluctuations far more orderly than the usual cosmic roar. These narrowband emissions, first identified as a persistent hum in interstellar plasma, spanned multiple frequencies with consistent amplitude and spacing, signatures of a filament channeling and amplifying plasma oscillations rather than scattering them. Inside these filaments, density microstructures, ripples just a few thousand kilometers across, trace turbulent cascades in the interstellar medium, yet remain remarkably coherent over distances of billions of kilometers. As Voyager 1 pierced the filament, its plasma wave instrument saw sudden shifts in electron density and magnetic field strength that mirror laboratory studies of filamentary turbulence, where charged flows swirl around magnetic cores and generate organized oscillations. This encounter suggests that interstellar space is laced with invisible wires of plasma that can focus energy and guide electromagnetic waves, much like fiber optics over cosmic scales. Decoding the precise waveform patterns from this filamentary passage could reveal the filament's internal geometry, magnetic topology, and even the spectrum of turbulence within. By mapping these cosmic strands, Voyager 1 offers humanity its first in-situ glimpse of the interstellar web, a network of plasma filaments sculpting galaxies and guiding particles through the darkness between stars. Physics rewritten. Voyager 1 just dared the universe to redefine itself when its instruments logged a cascade of interlinked anomalies. Energy spikes, patterned pulses, phantom torque, accelerated echoes, silent sectors, alien-style beams, dark energy distortions, and plasma filaments, all in one astonishing episode. This isn't science fiction, it's a reality check for centuries-old physics. Traditional models treat interstellar space as a passive backdrop, a near-empty expanse where cosmic rays and magnetic fields drift predictably. Voyager 1's data totally shatters that illusion, revealing a dynamic, interactive medium capable of bending space-time, guiding energy with dazzling precision, and even hosting phenomena that mimic intelligent design. If an advanced civilization's technology fine-tuned particle beams across light years, our theories of field propagation and energy dissipation will need a radical overhaul. If dark energy pockets truly warp electromagnetic signals in situ, we must rethink the scale invariance of fundamental forces and revisit cosmological constants. Should plasma filaments act like interstellar fiber optics, then turbulence theories and magneto-hydrodynamic simulations require major revisions. And if localized space-time warps shorten signal delays, we might finally glimpse pathways toward faster-than-light communication or travel, once banished to theoretical footnotes. Each hypothesis emerging from Voyager 1's impossible encounter demands new equations, fresh laboratory experiments, and innovative space missions. As scientists race to integrate these anomalies into coherent frameworks, textbooks will change, graduate programs will pivot, and the next generation of space probes could carry quantum sensors explicitly designed to map these exotic phenomena. Voyager 1, the humble messenger from humanity's past, has become the herald of physics' future, urging us to broaden our understanding of reality and embrace a cosmos that refuses to remain static or simple. Thanks for joining Simply Science on this incredible journey with Voyager 1's impossible encounter. If you enjoyed unraveling deep space mysteries, smash that subscribe button and ring the bell so you never miss our next cosmic discovery. Drop a comment below with your wildest theory about what Voyager might uncover next, and let's keep the conversation going. Your support helps us explore the universe one breakthrough at a time. See you in the next video, Space Explorers. In September of 2022, humanity officially became a cosmic force, capable of moving celestial objects through space. But what happened next, honestly, shocked even NASA's top scientists. When the DART spacecraft slammed into asteroid Dimorphos at 14,000 miles per hour, it didn't just nudge the space rock as planned. The impact created a 32-minute orbital change instead of the expected 10 minutes, proving our planetary defense technology is 3 times more powerful than we ever imagined. We didn't just deflect an asteroid, we revolutionized physics itself. The DART mission. What if I told you that on a Tuesday morning in September 2022, humanity officially became a space cowboy? That's exactly what happened when NASA's DART spacecraft smashed into asteroid Dimorphos at over 14,000 miles per hour, marking the first time our species deliberately changed the course of a celestial object. This wasn't just another space mission, this was our planetary defense debut. The double asteroid redirection test launched in November 2021 with one clear mission: prove we could knock an asteroid off course if one ever threatened Earth. Scientists chose Dimorphos, a football stadium-sized moon orbiting the larger asteroid Didymos, as the perfect target. Why? Because it was far enough away to be safe but close enough for telescopes to measure the results. The $325 million mission spent nearly a year traveling through space, guided by autonomous navigation systems that would steer the spacecraft into its target without human intervention. On September 26, 2022, at exactly 7:14 p.m. Eastern Daylight Time, DART completed its kamikaze mission, streaming live images back to Earth until the very moment of impact. Ground control erupted in cheers as confirmation arrived. Humanity had just taken its first real step toward becoming a spacefaring civilization capable of defending our home planet from cosmic threats. Impact results analysis. You know that moment when you throw a rock into a calm pond and watch the ripples spread? Well, multiply that by about 10 billion and you'll get close to what happened when DART hit Dimorphos. The moment of impact on September 26, 2022 created the most spectacular light show in our solar system, a massive debris plume that stretched over 10,000 kilometers into space, visible to telescopes across the globe. But here's the mind-blowing part. This wasn't just a little puff of dust. The impact crater ejected millions of tons of rock and debris at speeds reaching 500 meters per second, creating what scientists called a comet-like tail that persisted for months. Ground-based observatories and the Hubble Space Telescope captured breathtaking images, showing the asteroid system glowing like a distant star. The brightness increase was so dramatic that Dimorphos became 35 times brighter than normal, making it visible to amateur astronomers with basic equipment. What shocked researchers most was the duration of the debris cloud. Initial models predicted it would dissipate within days, but observations in November 2022 still showed active particle ejection. The European Southern Observatory tracked individual boulders the size of cars being hurled into space, while NASA's infrared telescopes detected the heat signature of the impact site glowing for weeks afterward. This spectacular aftermath proved that kinetic impact missions create far more dramatic and long-lasting effects than anyone had calculated. Momentum enhancement discovery. Scientists expected a gentle nudge. What they got was a cosmic sledgehammer effect that rewrote the laws of asteroid physics overnight. When NASA's mission planners originally calculated DART's impact, they predicted the collision would slow Dimorphos by exactly 10 minutes in its 11.9-hour orbit around Didymos. Conservative estimates based on laboratory simulations and computer models suggested this would be humanity's modest first step into planetary defense. But on October 11, 2022, when ground-based radar measurements finally confirmed the results, jaws dropped across the scientific community. The asteroid's orbital period had decreased by a staggering 32 minutes, more than triple the expected change. This wasn't just beating expectations, this was obliterating them. The momentum transfer efficiency reached 2.2 to 4.9 times higher than theoretical predictions, depending on which measurement method scientists used. Dr. Lori Glaze from NASA's Planetary Science Division called it a game-changing discovery that fundamentally altered our understanding of kinetic impactor technology. The reason? Dimorphos wasn't behaving like a solid rock, but more like a loose aggregate of boulders held together by weak gravity. When DART struck at 6.14 kilometers per second, it didn't just transfer its momentum, it triggered a massive recoil effect, as tons of debris shot out like a natural rocket thruster. This ejecta enhancement meant that future asteroid deflection missions could work with much smaller spacecraft than previously thought, revolutionizing our entire approach to planetary defense. Asteroid structure insights. Ever wondered what happens when you punch a pile of gravel versus a solid brick wall? That's exactly what DART's collision revealed about Dimorphos, and honestly, it completely shattered our assumptions about asteroid composition. Before September of 2022, scientists believed most asteroids were dense, rocky bodies that had formed billions of years ago during the early solar system. But when DART slammed into Dimorphos at 14,000 miles per hour, the impact didn't create the expected solid crater. Instead, it triggered what researchers called a catastrophic disruption that exposed the asteroid's true nature as a gravitationally bound rubble pile. High-resolution images from ground-based telescopes showed massive boulders, some the size of school buses, being ejected from the impact site, revealing that Dimorphos is essentially a loose collection of rocks held together by extremely weak gravitational forces. This discovery revolutionized our understanding of near-Earth objects, with Dr. Andy Rivkin from Johns Hopkins Applied Physics Laboratory confirming that 80% of asteroids in our cosmic neighborhood share this rubble pile structure. The implications are, well, staggering. These flying gravel heaps are much easier to deflect than solid asteroids, but they're also way more unpredictable in how they respond to impacts. Spectroscopic analysis conducted in late 2022 revealed that the ejected material contained primitive carbonaceous compounds dating back 4.6 billion years, making Dimorphos a time capsule from the solar system's violent birth. This insight means future deflection missions will need completely different strategies depending on whether they're targeting solid asteroids or these cosmic rubble piles. Strategic implications. What happens when humanity suddenly realizes it can literally move mountains in space? The moment DART's success was confirmed in October 2022, every space agency on Earth started rewriting their planetary defense playbooks. This wasn't just a scientific achievement, it was a species-level upgrade that transformed us from sitting ducks to active defenders of our cosmic neighborhood. The 32-minute orbital change proved that kinetic impactor technology could work with dramatically smaller spacecraft than previously calculated, meaning we could launch multiple deflection missions for the cost of one original estimate. NASA's Planetary Defense Coordination Office immediately began updating their threat assessment protocols, realizing that asteroids once considered too large to deflect were now manageable targets. But the implications go far beyond just Earth protection. International space treaties from the 1967 Outer Space Treaty suddenly needed modernization. Who has the authority to deflect an asteroid that might affect multiple countries? ESA's Director General Josef Aschbacher announced in early 2023 that the success had accelerated European Union space defense initiatives by at least 5 years. Meanwhile, China's National Space Administration and Russia's Roscosmos both fast-tracked their own asteroid deflection programs, creating a new space race focused on planetary protection rather than exploration. The most surprising strategic shift came from commercial space companies like SpaceX and Blue Origin, who began developing rapid response deflection systems that could be deployed within 18 months of asteroid detection, turning planetary defense from a decades-long project into something resembling an emergency response system. We officially entered the era where extinction-level threats became manageable engineering problems. Hera mission planning. What do you do when you've just pulled off humanity's greatest cosmic billiard shot and need to see the damage up close? You send in the forensic investigators. That's exactly what ESA's Hera mission represents, a $129 million space detective story launching in October 2024 to examine DART's crime scene with unprecedented detail. While DART was the muscle, Hera is the brains, equipped with advanced imaging systems and 2 CubeSat companions called Juventus and Milani that will map every crater, boulder, and debris trail left behind by the September 2022 impact. The mission will spend 2 years traveling to the Didymos system, arriving in late 2026 to conduct the most thorough asteroid autopsy in human history. Hera's instruments include high-resolution cameras, laser altimeters, and ground-penetrating radar that will create 3-dimensional maps showing exactly how Dimorphos deformed during impact. But here's where it gets fascinating. Juventus will actually land on Dimorphos and drill into its surface, analyzing the internal structure that made DART's momentum transfer so surprisingly effective. Meanwhile, Milani will study the dust environment and track particles still orbiting the asteroid system 4 years after impact. ESA's mission planners designed Hera to answer the biggest question: can we scale up this technology for real planetary threats? The data collected will feed directly into NASA's next-generation deflection systems, creating a complete blueprint for asteroid defense architecture. When Hera arrives at Didymos, it won't just be studying the past, it'll be engineering humanity's cosmic security system for the future. Planetary defense evolution. Remember when humanity's biggest space worry was whether satellites would crash into each other? Those days, honestly, officially ended when DART proved we could weaponize physics itself against cosmic threats. The September 2022 success didn't just validate one mission, it triggered a complete evolutionary leap in how our species approaches planetary defense. Within months of impact confirmation, space agencies worldwide began developing second-generation deflection technologies that frankly make DART look like a prototype. NASA's follow-up missions now include multiple kinetic impactors working in coordinated strikes, gravity tractors for precision orbit adjustments, and even nuclear pulse units for the most extreme scenarios. Japan's JAXA announced their 2028 Hayabusa X mission will test precision drilling techniques to alter asteroid rotation, while India's ISRO is developing swarm deflection technology using dozens of small spacecraft acting as a collective force. The most revolutionary change, though, came from private sector involvement. SpaceX began designing Falcon Heavy variants specifically for rapid asteroid response, cutting deployment time from years to months. ESA's 2025 Planetary Defense Conference established the International Asteroid Response Protocol, creating standardized procedures for global cooperation during real threats. But perhaps the biggest evolution is philosophical. We've shifted from reactive astronomy to proactive cosmic engineering. Ground-based surveys like NASA's NEO Surveyor and ESA's FlyEye telescopes now operate as early warning systems feeding directly into automated deflection networks. What started as humanity taking its first baby steps into planetary defense has evolved into a sophisticated cosmic immune system that actively monitors and neutralizes threats before they become extinction events. Mission success redefinition. When was the last time scientists had to completely rewrite what winning means in the middle of celebrating victory? Well, that's exactly what happened when DART's results came back showing a 32-minute orbital shift instead of the predicted 10 minutes. Suddenly, every planetary defense mission in development had to recalibrate their success metrics. Before October 2022, mission planners used these pretty conservative models based on solid asteroid physics and laboratory impact tests that assumed only modest momentum transfer rates. NASA's original benchmarks actually classified anything above 73 seconds of orbital change as a complete success, making DART's 32-minute achievement an almost 2,600% overperformance. This unexpected triumph forced JPL engineers to completely revise their deflection calculators and threat assessment algorithms. Dr. Tom Statler from NASA headquarters even admitted that success parameters for future missions like ESA's Hera and NASA's proposed NEO interceptor needed fundamental restructuring. The ripple effects were immediate asteroid deflection timelines that once required decades of advance warning could now work with just years of preparation. International space law committees had to redefine minimum deflection requirements for planetary protection protocols, while commercial space contractors realized they could bid for asteroid deflection contracts using much smaller, cheaper spacecraft. Most importantly, the scientific community learned that real-world asteroid physics operated on completely different principles than computer simulations suggested. Mission success was no longer about hitting predetermined targets. It was about adaptive engineering that could harness these unexpected physical phenomena. DART didn't just succeed, it redefined success itself, proving that sometimes the best victories are the ones that exceed every prediction and force humanity to dream bigger. Debris management and safety concerns. What happens when you create the largest artificial debris field in human history and suddenly realize it might come back to haunt you? That's the uncomfortable question NASA scientists faced when DART's impact on September 26, 2022 scattered millions of tons of asteroid fragments across space at velocities reaching 500 meters per second. While everyone celebrated the 32-minute orbital success, space debris experts quietly began tracking what they called the dimorphos particle cloud, an expanding sphere of rocky projectiles that could pose risks to future spacecraft missions. ESA's Space Debris Office immediately activated enhanced tracking protocols using ground-based radar systems to monitor the largest fragments, some weighing several tons and traveling on unpredictable trajectories. The October 2022 debris analysis revealed that particles were spreading far beyond the Didymos system, with some fragments potentially reaching Earth-crossing orbits within decades. Commercial satellite operators like SpaceX and OneWeb began incorporating DART debris models into their collision avoidance systems, while NASA's Orbital Debris Program Office updated their space traffic management protocols to account for artificial asteroid fragmentation. The most concerning discovery came in early 2023 when optical telescopes detected boulder-sized chunks still being ejected from Dimorphos months after impact, suggesting the asteroid was experiencing ongoing structural collapse. International Space Station mission planners now include DART debris assessments in their orbital safety calculations, and future asteroid deflection missions must prove they won't create navigational hazards for deep space exploration. The irony is pretty striking. Humanity's first successful planetary defense created our first interplanetary pollution problem. Precision requirements for real threats. What good is humanity's newfound cosmic billiard skills if we can't hit the balls that actually matter? While DART's triumph against Dimorphos was spectacular, deflecting a real Earth-threatening asteroid requires precision levels that make Swiss watchmaking look like finger painting. The sobering reality hit scientists in early 2023 when they calculated the exact requirements for real planetary defense scenarios. Unlike Dimorphos, which was a harmless test target 11 million kilometers away, an actual extinction-level asteroid would need deflection decades before impact, and missing by even 0.01% could mean the difference between a near miss and global catastrophe. NASA's Planetary Defense Office revealed that successful deflection of a 1-kilometer asteroid discovered just 10 years before Earth impact would require trajectory accuracy within 10 meters at the moment of collision. Imagine threading a needle while blindfolded and riding a rocket. The challenge multiplies when dealing with fast-rotating asteroids or binary systems like Didymos, where gravitational interactions can amplify small errors into massive miscalculations. ESA's trajectory modeling in 2024 showed that deflecting Apophis during its 2029 close approach would demand navigation precision exceeding anything achieved in human spaceflight history. Perhaps most daunting, detection systems like NASA's NEOWISE and the upcoming NEO Surveyor must provide asteroid composition data, rotation periods, and structural characteristics years in advance because with real threats there are no second chances. DART proved we can move asteroids, but defending Earth means hitting cosmic bullseyes with zero margin for error. And that's how humanity officially became cosmic defenders in just one incredible impact. From DART's sledgehammer effect to the 32-minute orbital miracle, we've proven that extinction-level threats are now manageable engineering problems. But this is just the beginning of our planetary defense evolution. What amazed you most about DART's discoveries? Drop your thoughts in the comments below. I read every single one. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss Simply Science breaking down the universe's most incredible mysteries. Until next time, keep exploring. It started as nothing more than a flicker, barely a whisper in the data streams flowing from observatories around the world. But when James Webb Space Telescope captured its first detailed image of the mysterious interstellar visitor 3Y Atlas, scientists realized they were witnessing something that could rewrite our understanding of the cosmos. This ancient traveler from beyond our solar system carries secrets that challenge everything we thought we knew about space. The flicker in the dark. The discovery of 3Y Atlas started, not with a bang, but with a faint cosmic flicker detected by the Atlas telescope at Rio Hurtado, Chile in early July 2025. Astrophysicist Matthew Payne at the Minor Planet Center was among the first to flag its interstellar trajectory, confirming that what began as a whisper in Atlas survey data was unlike anything bound to our sun. Days later, a global alert went out to observatories worldwide, and research teams coordinated with NASA's JWS team to track this mysterious visitor. This collective effort led to the crucial moment when NASA released its first image, ultra-detailed and definitive, immediately captivating Dr. Payne's team and the world's top interstellar object researchers. The initial detection required sophisticated computer algorithms to distinguish the object's movement against the crowded stellar background near the constellation Sagittarius. Multiple observatories confirmed the unusual motion patterns within 48 hours, establishing international protocols for rapid follow-up observations. The discovery highlighted how advanced survey systems have revolutionized our ability to detect cosmic visitors that would have remained invisible just decades ago. Beyond the solar veil. Pinpointing the origin, the Atlas team led by Larry Deneau confirmed 3Y Atlas's interstellar status, distinguishing it by its hyperbolic excess velocity well above the escape velocity from the Sun. Analysis by Dr. Karen Meach, who also characterized Oumuamua, showed the orbital data marked its point of entry far above the ecliptic, entering from deep space. Observatories from the European Southern Observatory to Mauna Kea, Hawaii, contributed positional data that painted a picture of an object traveling for potentially millions of years through interstellar space. These collaborative efforts proved this was the third object after Oumuamua and Borisov to have entered from outside the solar system, sparking a fast-tracked global campaign to track and analyze it before it disappeared forever. The object's trajectory suggested it had been wandering the galaxy for eons, carrying pristine materials from its unknown stellar birthplace. International astronomers worked around the clock to maximize observation time, knowing that such visitors offer rare glimpses into the composition and conditions of distant star systems. The coordinated response demonstrated how the astronomical community has learned from previous missed opportunities with earlier interstellar visitors. The accelerating mystery. Why does 3I Atlas exhibit velocity patterns that fundamentally challenge our understanding of celestial mechanics? Scientists conducting comprehensive trajectory analysis have discovered that this enigmatic interstellar visitor displays acceleration characteristics completely unlike typical comets or asteroids native to our solar system. While most celestial objects follow precisely predictable orbital paths determined exclusively by gravitational influences from the Sun and planets, 3I Atlas demonstrates subtle yet scientifically significant deviations from all expected trajectories based on conventional physics models. These anomalous acceleration patterns strongly suggest that forces extending far beyond simple gravitational attraction are actively influencing its motion through space in ways that current astrophysics cannot fully explain. The object's peculiar behavior bears striking resemblance to that of one Oumuamua, which famously displayed mysterious non-gravitational acceleration that completely baffled the global scientific community and sparked intensely controversial theories about possible artificial origins. Early observational data revealed 3I Atlas beginning active cometary outgassing while still positioned 4.5 astronomical units from the Sun, a distance much greater than where typical solar system comets begin their characteristic, volatile sublimation processes. This remarkably early activation, combined with its highly unusual velocity profile and trajectory characteristics, creates an accelerating scientific mystery that fundamentally challenges conventional theoretical models of cometary physics and interstellar object behavior. The extraordinary combination of extreme hyperbolic velocity, unprecedented trajectory parameters, and completely anomalous acceleration signatures has forced astronomers worldwide to seriously reconsider fundamental assumptions about how interstellar objects behave when passing through alien star systems, opening entirely new avenues of research into the complex dynamics governing these mysterious cosmic wanderers. Patterns in the void. The intrigue deepened when the Vera C. Rubin Observatory Analysis Group, led by Dr. Zdenka Vokrulicki, noted a trend in the frequency of interstellar objects visiting our solar system. Since the surprise of Oumuamua in October 2017 and 2I/Borisov in December 2019, detection rates have steadily increased, thanks to improved survey technology and, better international coordination. The International Astronomical Union actually convened a special panel to discuss the implications for galactic object exchange, stressing that the regular arrival of such bodies really challenges previous models of solar system isolation. Each confirmed object, now that's 3 in under a decade, forces a rewriting of our assumptions about material drifting between stars and the dynamic nature of our galactic neighborhood. Statistical analysis suggests that thousands of similar objects pass through the outer solar system undetected each year, representing a vast population of interstellar wanderers. The pattern indicates that our solar system sits within a stream of cosmic debris ejected from stellar systems throughout the Milky Way galaxy. And advanced detection capabilities promise to reveal many more such visitors, fundamentally changing our understanding of how matter moves between star systems and the frequency of interstellar exchanges. The machine hypothesis. New Webb imagery processed by the Space Telescope Science Institute in Baltimore and interpreted by a multidisciplinary panel led in part by Dr. Avi Loeb set off debate on possible artificial origins. Loeb highlighted unexpected geometry in the object right-angle reflectivity patterns and non-random surface features that seemed inconsistent with natural formation processes. The European Space Agency's JWST spectroscopy division found thermally anomalous regions and odd shadowing that defied conventional models of cometary behavior. Team member Dr. Heidi Hamel, planetary scientist and JWST co-investigator, cautioned that such findings don't yet confirm technology, but the conversation around the machine hypothesis went global after unexpected press releases. The object's surface appeared remarkably smooth and uniform, lacking the irregular features typical of natural space debris that's been battered by cosmic rays and micrometeorites during interstellar travel. Advanced imaging revealed geometric patterns that some researchers interpreted as possible structural elements, though others argued these could result from unusual crystallization processes during the object's formation. The debate really highlighted the challenges of distinguishing between natural and artificial characteristics when examining objects from unknown stellar environments with, well, potentially different formation conditions. Spectral secrets. Spectroscopic data from the James Webb NIRSpec instrument showed 3I/Atlas contains unfamiliar mixtures of organics, silicates, and metallic alloys, not typical for solar system comets. Dr. Alan Fitzsimmons from Queen's University Belfast identified a significant absorption at 1.5 microns, associated with hydrated minerals, alongside anomalous emission lines unexplained by water or carbon dioxide alone. NASA's Goddard Space Flight Center provided confirmation, reporting faint but consistent microwave emissions that suggested active internal processes. Dr. Jessica Agarwal from the German Aerospace Center noted these combined features could suggest prior irradiation or artificial alteration of native ices, fueling both natural and technological hypotheses about the object's origin. The spectral signatures revealed isotopic ratios that differed from typical solar system materials, indicating formation in an environment with different stellar nucleosynthesis products. Rare Earth elements appeared in concentrations that challenged existing models of planetary formation and cometary composition. And the presence of complex organic molecules typically associated with biological processes sparked additional speculation, though researchers emphasized that such compounds can form through natural chemical processes in interstellar space. The information blackout. So, amid mounting discoveries, global scientists started to notice restricted access to JWST raw data beginning on August 18, 2025. Dr. Joseph Maciero of the Planetary Defense Coordination Office testified that agency data review protocols were now being applied to 3I/Atlas, and well, he cited national security as the reason for limiting information sharing. Meanwhile, SETI Institute researchers, led by Dr. Jill Tarter, raised open letters demanding transparency, and the European Space Agency's Gaia mission team quietly shared independent astrometry with their international colleagues. Tensions really flared during an American Astronomical Society session, when international collaboration took a back seat to agency security reviews. This just revealed the growing friction between open science and government oversight on cosmic anomalies. Scientists expressed a lot of frustration that crucial observation windows were being compromised by bureaucratic delays and, honestly, classification concerns. The controversy really highlighted some fundamental questions about who controls access to cosmic discoveries and whether potential extraterrestrial contact should be subject to governmental secrecy. In response, international researchers began developing independent observation networks to ensure that scientific data would remain accessible to the global community, regardless of individual government policies regarding space-based discoveries and their potential implications for national security. Controlled heat and hidden intent. Thermal mapping using Webb MIRI instruments, supervised by Dr. Michael Werner at JPL, exhibited these adaptive temperature zones across the object's surface, which honestly is not something you see in typical comets. Dr. Christina Thomas at Northern Arizona University presented findings of synchronous heat regulation, and that really stands out, especially when you compare it to the chaotic surface cooling we've seen on icy nuclei, like 67P Churyumov-Gerasimenko. Now, key data obtained near perihelion on August 19, 2025, revealed the stabilization of energy emission regions that actually seem to respond intelligently to solar heating. Theorist Dr. Gregory Laughlin at Yale even hypothesized that such signatures might imply, quote, thermal shielding or technology for intent-driven adaptation, a radical but now openly discussed possibility among planetary scientists. The temperature control followed these predictable patterns that maintained optimal conditions for preserving internal structures, and that honestly suggests either remarkable natural adaptation or deliberate engineering. Computer models showed that natural processes alone just couldn't account for the precision of thermal regulation observed across different surface regions. What's even more surprising is that the controlled heating patterns persisted, even as the object moved through varying solar radiation intensities, indicating active, rather than passive, thermal management systems that really defy our conventional understanding of cometary physics. The prime number message. Analysis teams at the Max Planck Institute for Radio Astronomy, led by Dr. Michael Kramer, detected heat emission modulations that, after Fourier transformation, revealed repeated prime number sequences embedded in the thermal output. Dr. Sophia Sheikh, a SETI researcher, independently validated a 17-23-31 pattern in night-to-night thermal variations using Green Bank Observatory data and, well, some pretty sophisticated signal processing techniques. This prime encoding is considered by scientists, as originally argued by Carl Sagan, to be the most likely signal structure used by non-human intelligences trying to communicate across interstellar distances. The findings, if verified by international SETI groups, could actually represent the first candidate evidence for information intentionally encoded in a celestial object passing through our solar system. The mathematical sequences appeared with statistical significance far exceeding random thermal fluctuations, suggesting deliberate modulation of heat emission patterns. Multiple independent verification attempts confirmed those prime number sequences across different observation periods and wavelengths. The discovery prompted emergency sessions at SETI institutes worldwide, as researchers grappled with the possibility that, just maybe, humanity had detected its first confirmed extraterrestrial communication attempt, though, of course, skeptics continued to search for natural explanations. The Watchers and the Watched. With the International Astronomical Union's special session, the world watched as experts like Dr. Lisa Kaltenegger from Cornell, astrobiologist Dr. Sarah Seeger, Planetary Protection Officer Dr. Catherine Conley, and SETI pioneer Frank Drake reflected on the profound implications of these discoveries. The paradigm has fundamentally shifted. The idea that humanity is the primary watcher of the cosmos has, well, inverted, with 3I Atlas representing potential evidence that we ourselves are being observed and studied. This reversal sparks some really intense debate about whether ethical and existential responsibilities should ever be confirmed, especially with direct, possibly intentional signatures detected in a passing interstellar visitor. The story of 3I Atlas will shape cosmic policy, philosophy, and planetary science for decades to come as humanity grapples with its changing role in the universe. Scientists are now developing new protocols for handling potential extraterrestrial contact scenarios, recognizing that traditional assumptions about human cosmic isolation may no longer apply. The discovery has prompted philosophical discussions about humanity's readiness for contact with advanced civilizations and the implications of being observed by intelligence that may have been studying Earth for extended periods. International cooperation frameworks are being established to ensure unified responses to future encounters with potentially artificial interstellar objects. The first real image from the James Webb Space Telescope begins a bold chapter in cosmic history. As data pours in and global teams compete and cooperate across boundaries, 3I Atlas stands as both a scientific puzzle and a reminder of our shared curiosity about the universe. The search for answers continues to accelerate with each new discovery. Keep exploring the cosmos with Simply Science. Like, share, and subscribe for our next cosmic revelation. Did you know that every atom in your body was forged inside the nuclear furnace of a dying star billions of years ago? You are literally made of stardust that has traveled across the galaxy for eons before becoming part of you. Carl Sagan wasn't being poetic when he said, "We are made of star stuff." He was stating a profound scientific truth that connects every human being to the cosmos in the most intimate way possible. But here's what will blow your mind. Do you know which elements in your body came from the most violent explosions in the universe? The discovery that shocked astronomers. Alarms started blaring at observatories across 3 continents when the data came in. Something massive was barreling through our solar system, and it wasn't supposed to be there. Just weeks ago, the most sensitive gravitational wave detectors on Earth picked up an anomaly that made veteran astronomers do double takes at their screens. This wasn't your typical asteroid or comet announcement buried in some obscure scientific journal. This was an emergency alert that had space agencies scrambling to redirect their most powerful telescopes toward a single point in space. The object's gravitational signature was so pronounced that it actually bent the trajectory of nearby space debris, creating a cosmic wake that screamed, "I'm here," to anyone paying attention. What really sent shockwaves through the scientific community wasn't just the size, though at 10 times larger than Oumuamua, it's absolutely colossal, but the timing. 2 interstellar visitors in less than a decade defies every statistical model we have about these cosmic wanderers. The discovery team at the European Southern Observatory couldn't believe their instruments at first, running diagnostics 3 times before accepting what they were seeing. Unlike Oumuamua's stealthy approach that caught us completely off guard, this behemoth announced its presence like a cosmic freight train, giving us unprecedented advance warning, and the chance to study an interstellar visitor while it's still approaching rather than racing away from us. Size comparison. What if I told you that right now, something the size of Manhattan is silently cruising through our solar system at 26 kilometers per second? This new interstellar visitor makes Oumuamua look like a pebble next to a skyscraper. We're talking about an object so massive that if you placed it next to the Empire State Building, the building would look like a toothpick. To put this in perspective that'll blow your mind, Oumuamua was roughly 400 meters long, about the length of 4 football fields. This new cosmic giant? We're looking at something approaching 4 kilometers in length. That's not just big, that's monumentally huge by space rock standards. The sheer volume difference is staggering. You could fit over 1,000 Oumuamuas inside this thing and still have room left over. When astronomers first calculated its dimensions, they had to recalibrate their instruments because the readings seemed impossible. This isn't just another space rock drifting through the void. This is a cosmic mountain, a wandering piece of another star system that somehow found its way to our neighborhood. The gravitational influence alone is enough to slightly alter the orbits of smaller asteroids in its path. If Oumuamua was nature's postcard from another star system, this new visitor is like receiving an entire encyclopedia. The amount of data we can gather from something this size could revolutionize our understanding of interstellar objects and the distant worlds they come from. We're witnessing something that happens maybe once in a human lifetime. The trajectory mystery. Every computer model says this shouldn't exist, yet here it is, defying the laws of celestial mechanics as we know them. This massive interstellar wanderer is following a hyperbolic orbit so extreme that it's rewriting textbooks on how objects move through space. Unlike anything in our solar system that follows predictable elliptical paths around the sun, this cosmic giant is on a one-way ticket to nowhere, traveling on a trajectory that screams, "I'm not from around here." What's absolutely mind-bending is where it came from. Deep space analysis suggests this visitor originated from a stellar region over 100 light-years away, meaning it's been traveling through the cosmic void for potentially millions of years before stumbling into our neighborhood. The orbital mechanics team at NASA had to create entirely new calculation models because this object's path doesn't match any known gravitational influences in our solar system. It's approaching from an angle that suggests it came from the direction of the constellation Lyra. But here's where it gets really weird. Its velocity and trajectory indicate it may have been gravitationally slingshot by multiple star systems during its epic journey across the galaxy. The precision of its path is so mathematically perfect that some scientists are questioning whether this could be natural at all. This isn't just a random space rock that happened to wander into our solar system. This is a cosmic bullet fired from the depths of interstellar space with surgical precision, following a trajectory that will take it past our sun and back out into the infinite darkness of deep space. Composition secrets revealed. Scientists just discovered something that's making them question everything they thought they knew about space rocks. This interstellar giant isn't made of what it should be made of. When the first spectral analysis data came back from the Hubble Space Telescope, the research team stared at their screens in complete bewilderment because the light signatures were unlike anything in our cosmic catalog. This massive visitor is reflecting sunlight in patterns that suggest a composition so bizarre it's forcing astronomers to rewrite the periodic table of space objects. The surface appears to be a patchwork of materials that shouldn't exist together. Metallic compounds mixed with crystalline structures that only form under extreme pressure conditions found in the cores of dying stars. What's absolutely fascinating is that different sections of the object are showing completely different spectral signatures, as if it's a cosmic Frankenstein monster assembled from the remnants of multiple stellar systems. The infrared readings reveal temperature variations across its surface that indicate some areas are absorbing heat while others are reflecting it, creating a thermal map that looks more like abstract art than natural geology. Most shocking of all, there are regions showing traces of rare earth elements that are virtually impossible to find in natural asteroids, leading some researchers to wonder if we're looking at processed materials rather than raw space rock. The chemical fingerprint is so unique that it's like nothing we've ever encountered in our solar system, suggesting this wandering giant carries the geological history of alien worlds within its very structure. The acceleration anomaly returns. Houston, we have a problem, and it's accelerating when it absolutely shouldn't be. Just like Oumuamua's infamous speed boost that left scientists scratching their heads, this colossal interstellar visitor is pulling the exact same impossible stunt, but on a scale that's making physicists lose sleep worldwide. As this massive object approaches our sun, it's gaining velocity in ways that completely violate our understanding of orbital mechanics, speeding up without any visible propulsion system or outgassing that could explain the acceleration. The numbers are absolutely staggering. We're talking about a 4-kilometer-long object somehow adding an extra 0.3 kilometers per second to its velocity, which in space terms is like a freight train suddenly sprouting rocket boosters. What's driving the scientific community absolutely crazy is that this acceleration is happening in a perfectly controlled manner, not the chaotic bursts you'd expect from natural phenomena like comet outgassing or solar radiation pressure. The trajectory calculations show this speed increase is so precise, it's almost like someone is gently pressing the accelerator pedal on a cosmic spacecraft. Multiple observatories have confirmed the readings, ruling out measurement errors, which means we're witnessing something that challenges the fundamental laws of physics as we know them. The most unsettling part, the acceleration pattern is nearly identical to Oumuamua's, suggesting these interstellar visitors share some mysterious propulsion mechanism that we simply don't understand. Two objects separated by years and vastly different in size, both exhibiting the same impossible behavior, coincidence, or something far more extraordinary. Why scientists are freaking out. The coffee machines at observatories worldwide are working overtime because astronomers can't sleep, and for good reason. Two massive interstellar objects visiting our solar system within a single decade has shattered every statistical model we've relied on for predicting cosmic events. According to our best calculations, we should see maybe one interstellar visitor every few thousand years, yet here we are with two giants that have decided to drop by for a cosmic house call in what amounts to a cosmic blink of an eye. The probability of this happening naturally is so astronomically low that it's like winning the lottery while being struck by lightning during a solar eclipse. What's keeping scientists awake at night isn't just the timing, it's the eerie similarities between these visitors that suggest we might be witnessing the beginning of something unprecedented in human history. Research teams are frantically revising their models of interstellar object frequency, and the new numbers are painting a picture that nobody expected. Some leading astrophysicists are quietly suggesting that our galaxy might be far more crowded with wandering objects than we ever imagined, or worse, that something is actively sending these massive visitors our way. The European Space Agency has already fast-tracked 3 emergency research projects to study this phenomenon, while NASA is redirecting resources from other missions to focus entirely on these mysterious wanderers. The scientific community is buzzing with theories ranging from natural galactic cycles to artificial intervention. But one thing is certain, our understanding of the cosmos just got turned completely upside down. The alien technology debate. So, what happens when the world's most respected scientists start whispering about artificial intelligence in the hallways of Harvard and MIT? The arrival of this second massive interstellar visitor has, honestly, reignited the most controversial debate in modern astronomy. Are we looking at natural space rocks or, something far more extraordinary? While the scientific establishment tries to keep their professional composure in public, behind closed doors, heated discussions are erupting about the possibility that these objects might actually be probes from distant civilizations. The timing, the similar acceleration patterns, and those bizarre compositions are creating a perfect storm of evidence that's making even the most skeptical researchers question their assumptions. Dr. Avi Loeb, the Harvard astrophysicist who famously suggested Oumuamua could be artificial, is now pointing to this new visitor as potential confirmation of his theories. The mathematical precision of both objects' trajectories, combined with their inexplicable acceleration, is displaying characteristics that, well, some argue are more consistent with engineered systems than with natural phenomena. What's particularly unsettling is how both visitors seem to be following optimal paths for maximum solar system observation. Almost as if they're conducting a systematic survey of our cosmic neighborhood. The scientific community is split between those desperately seeking natural explanations and a growing minority who believe we might be witnessing humanity's first contact with extraterrestrial technology. Government space agencies are, for now, remaining diplomatically silent, but insider reports suggest classified meetings are happening at the highest levels to discuss the implications of what we might actually be observing. What makes this one different? While Oumuamua played cosmic hide-and-seek with us for just a few months before vanishing into the void, this colossal newcomer is giving humanity the ultimate gift: time. Unlike its predecessor's lightning-fast flyby that left scientists scrambling to gather data before it disappeared forever, this massive interstellar giant's sheer size and trajectory mean we'll have an unprecedented window of opportunity to unlock its secrets. The difference is absolutely game-changing. Where Oumuamua was like trying to photograph a speeding bullet in the dark, this new visitor is more like having a slow-moving freight train that we can study from every conceivable angle. Space agencies worldwide are treating this as the scientific opportunity of a lifetime, with multiple nations already announcing emergency funding for dedicated observation missions. The European Space Agency has fast-tracked 3 separate probe launches, while NASA is retrofitting existing satellites to focus exclusively on this cosmic wanderer. What's particularly exciting is that this object's size means we can use ground-based telescopes to gather detailed surface mapping data that was impossible with Oumuamua's smaller profile. The extended observation period will allow us to track seasonal changes, monitor its mysterious acceleration patterns over months rather than weeks, and potentially solve the riddle that has haunted astronomers since 2017. This isn't just another interstellar visitor, it's our cosmic Rosetta Stone, offering the chance to finally understand what these mysterious wanderers really are, and where they come from in the vast expanse of space. The timeline. Mark your calendars because humanity is about to witness the cosmic event of the century, and missing it would be like skipping the moon landing all over again. This interstellar behemoth is currently racing toward its closest approach to our sun, scheduled for the coming months, creating a once-in-a-lifetime opportunity that won't repeat for potentially thousands of years. The timeline is absolutely perfect for maximum scientific observation. We're talking about a cosmic alignment that astronomers could only dream of just decades ago. As this massive visitor swings around our sun in what scientists are calling the golden observation window, it will be positioned for optimal viewing from Earth-based telescopes and space-based instruments simultaneously. The approach trajectory means that for several weeks this object will be close enough for detailed surface analysis while still far enough away to observe safely without solar interference. What makes this timeline even more extraordinary is that the object's path will take it through multiple optimal viewing zones, giving different regions of Earth prime observation opportunities at different times. Amateur astronomers with decent telescopes will actually be able to spot this cosmic giant during its closest approach, making this a truly democratic space event where professional scientists and backyard stargazers can participate together. The European Southern Observatory has already released viewing schedules for the public, while NASA is planning live streaming events to share real-time data as it comes in. This isn't just a scientific milestone, it's a moment when all of humanity can look up at the same cosmic visitor and wonder about the mysteries of deep space together. What this means for humanity. Every generation gets one moment that fundamentally changes how we see our place in the universe, and we're living through ours right now. These massive interstellar messengers aren't just cosmic curiosities floating through space. They're revolutionary time capsules carrying the geological fingerprints of alien worlds that existed billions of years before Earth even formed. Each of these wandering giants represents a direct physical connection to star systems so distant that their light takes centuries to reach us. Yet here we are, able to touch their surfaces with our instruments and decode their ancient secrets. The implications are staggering. We're essentially conducting archaeology on objects that have witnessed the birth and death of countless stars, survived supernovas, and drifted through the cosmic void while carrying pristine samples from the far reaches of our galaxy. What makes this discovery truly transformative is that it's shattering our cosmic loneliness, proving that our solar system isn't an isolated island, but rather a busy intersection in a galactic highway filled with wandering worlds. The data we're gathering from these visitors is rewriting textbooks on planetary formation, stellar evolution, and the very nature of how matter moves through space. Future generations will look back at this moment as the turning point when humanity first began to understand that we're part of a dynamic, interconnected cosmic community where worlds regularly exchange materials across impossible distances. These aren't just space rocks, they're ambassadors from the deep cosmos, offering us our first real glimpse into the true nature of our galactic neighborhood. That's a wrap on another mind-bending journey through the cosmos. These interstellar visitors are just the beginning of what promises to be an incredible era of space discovery. What do you think? Are we witnessing natural phenomena or something far more extraordinary? Drop your wildest theories in the comments below because I absolutely love reading your thoughts. If this cosmic mystery fascinated you as much as it did me, smash that subscribe button, and don't forget to hit the bell icon so you never miss our latest space revelations. Until next time, keep looking up and questioning everything. This is Simply Science, and we'll see you in the next video.